So now that we know about intersections and unions, we can bring in Venn diagrams. So Venn diagrams are used to illustrate the relationships between two or more sets. So let's look at an example. Going back to those sets A, B, and C that we talked about in the last example. Illustrate the relationships between sets A and set C using a Venn diagram. So to do that, we draw a rectangle for the Venn diagram. And then we'll draw a circle for set A and an overlapping circle for set C. All right, so what goes in the middle where these circles overlap is the intersection. So the values that are in both A and C. So we said the intersection of A and C, it looks like, are red and blue and yellow. I did not make this big enough. Yellow is also in there. All right, so I counted all of those. So what's in this part of A is going to be the elements that are in A that are not in C. So that's just going to be green. So green is a part of set A, but it's not a part of set C. So that's why it's not in that overlapping part. And then what are we missing that's in C but not in set A? So that's orange and purple. So you can see if I look at this, let's see, I'm going to use a different color here. This circle of C contains all the colors in C: red, orange, yellow, blue, purple. And then we can see in this little small part where the red, blue, and yellow happen, that's in C, but it's also in A. So when I look at the circle A, I've got green, red, blue, and yellow. Okay, so now if I'm having to illustrate the relationship between set A, B, and C using a Venn diagram, all right, so this is going to be a bigger one. So I am going to, let's see. Oh, and you know what? The one thing I'm missing is this rectangle is the universal set. So we have to also say the elements that are in the universal set that are not in A and C. So let's see if there's any of those that are missing. So red I've taken care of, orange, yellow, blue, purple, green. So actually we're okay. So illustrate the relationship between sets A, B, and C. So when you have three of them, you'll draw two circles that are overlapping on top. And then we'll draw a circle on the bottom. So again, where these intersect, that's the intersection of these sets. So let's see. So if I was looking at set A and set B, so what's in both A and B? Well, I see red is in both A and B, and green is in both A and B. But actually, before I do that, I shouldn't have started there. You always want to kind of start in the middle. So this piece right here includes circle A, circle B, and circle C. So let's do the intersection of all of them. So what do they all have in common? They all have red as an element. So that's the first one I'm going to do. So red is in A, B, and C. Okay, so now we can do this little chunk here. So I've counted red already as an overlap. But what's in just A and B but not C? So where do A and B overlap? And that's going to be in green. I've already counted red. So again, this whole thing says green and red are in both A and B, and specifically red is in both A, B, and C. If I looked at this chunk here, this is where A and C overlap. I've already said red, so let's see where A and C also overlap, and we've said that's going to be blue and yellow. This chunk right here is going to be where blue and C overlap. I've already counted red. So where else do blue and C B and C overlap? And it looks like they have orange. All right, now we need to see what we have left. So for set A, red is already taken care of, blue is already taken care of, yellow is already taken care of, and green's already taken care of. So that means there's nothing in this section here. There's nothing that's just in A that isn't in the other element sets. For B, red, orange, and green is already taken care of, so B is set. For C, we've got red, orange, yellow, blue. The one that we haven't listed yet is purple. So purple is an element in set C that is neither in A or B. So doing these types of things for Venn diagrams, setting them up this way, is what ends up really helping us organize a bunch of data, which we're going to do in a few slides. So Venn diagrams can be used to illustrate the intersections, unions, and complements of sets as shown in the image below. So you can see the intersection is where the shading of the two sets overlaps in the center. It contains the elements of both A and B. The union includes all of the elements in A, B, and A and B. And then the complement is everything that's not in the set, but that's out in the universe. So let's look at an example. A survey asks 200 people 2 questions. Do you have a cat? Do you have a dog? 80 responded that they had a dog, 105 said they had a cat, and 25 said they had both. Illustrate these results in a Venn diagram. How many people own a cat or a dog? So looking at this, I can't figure out how many own a cat or a dog. I think a lot of us would want to be like, oh, let's just add these up. So we'd have 185. But we're probably counting someone multiple times because there's people that have both. So creating this Venn diagram is what's going to really help us organize all this data. So it looks like we have 2 sets here. We have the set of dogs and we have the set of cats. And in total, there were 200 people that were questioned. So some of them might not have a dog or a cat. So again, start in the middle. So 25 said they had both. So that goes right in this intersection here. So 25 had a dog and a cat. So now we can kind of work backwards. 80 people said that they had a dog. They didn't say they only had a dog. They just said they had a dog. So to figure out what's left to put in this circle, we would do 80 minus 25 since I've already counted 25. And that leaves me with 45 people that have just a dog. And again, when you add this 45 plus 25, you'll get the 80 that responded to having a dog. For a cat, 105 said they had a cat. So to figure out who just had a cat, we need to take out those people who said they had both, which leaves me with 70. So there's 70 people that had just a cat. Now let's figure out how many people had neither. So to figure out what's in that universal set, we'll take the total amount of people that were surveyed, and we're going to subtract 45 from it, so the people that just had cats, 70 the people that just had dogs. Sorry, I just switched that around. People that just had dogs minus the people that just had cats minus people that had both dogs and cats. And that ends up leaving us with 50. So there's 50 people that have neither a cat or a dog. So we put that 50 in there to notate that universal set. So if I'm asked how many people own a dog or cat or a dog, so that's finding that union, because remember, or can be one or the other or both. So we're finding the union of the cat and dog. So that would be adding up all of those regions. So 45 plus 25 plus 70, which equals 150. So there were 150 people that owned a cat or a dog. Let's look at another example. A survey was given whether people asking people which streaming service they use, Netflix, Hulu, or YouTube TV. 52 only use Netflix, 62 only use Hulu, 24 only use YouTube TV, 16 use only YouTube TV and Hulu. 48 use only Netflix and Hulu, 30 use only YouTube TV and Netflix, 10 use all 3, and 25 use none of these. This is a lot of information, and so we need to organize it so I can actually understand this data. So again, this is where Venn diagrams comes into play. So it looks like we have 3 sets, Netflix, Hulu, and YouTube TV. So we're going to draw 3 overlapping circles. So we'll call that one N for Netflix, H for Hulu, and Y for YouTube TV. So again, we start in the middle. So we know that, excuse me, we know that 10 people used all 3. So that overlapping part where all three circles overlap is 10. They also told us that 25 use none of these, so that means there's 25 that are not in any circle. Here, 48 use only Netflix and Hulu. So that means this part right here where just the Netflix and Hulu circles overlap is 48. 30 use only YouTube TV and Netflix. So that's going to be right here for 30. And then we've got 24 only use YouTube TV. 16 only use YouTube TV and TiVo, or in Hulu. I use TiVo. And then 52 only use Netflix and 62 only use Hulu. So we can see now all of this data put together. We can even use that to figure out how many people total were in this survey. And to figure that out, we would add up 52 plus 48 plus 62 plus 24 plus 16 plus 30 plus 10 plus 25. We can figure out how many people used just Hulu and YouTube by looking right here at the 16. How many people watch YouTube? So how many people that were surveyed watch YouTube? Notice I didn't say only YouTube, I just said how many people watch YouTube. So that would be adding up all the values in the YouTube circle. So that would be 30 plus 10 plus 16 plus 24, which ends up giving us 30 plus 10 is 40, 80. So 80 people watch YouTube. So by organizing all of this data, it just gives us such a better way to be able to extrapolate things from it. Let's do one more example where we're dealing with data. Okay, let's look at another example. A survey asked people what alternative transportation modes they use. Use the data to complete a Venn diagram, then determine A, what percentage of people only ride the bus, and B, what percentage of people do not use any alternative transportation. So the data shows 30% use the bus, 20% ride a bike, 25% walk, 5% use the bus and ride a bike, 10% ride a bike and walk, 12% use the bus and walk, and 2% use all three. This for sure calls for a Venn diagram to organize this information a little bit better, because notice they didn't use the words only here. 30% use the bus. They didn't say only use the bus. So that means that of everyone that uses the bus, so that means they could walk too, they could ride their bike too. When you add all those up, it's 30%. So let's organize this. We're going to have 3 different sets. We've got the bike, the bus, and the walk. So again, I always start in the middle. So 2% use all 3. So in the overlapping of all 3 circles is where that 2% comes from. 10% ride a bike and walk. So that means this, where those 2 overlap, and again, it doesn't say only ride a bus and walk. If it said only, we would put 10% here, but it doesn't. It just says all together, 10% of people ride a bus and walk. So I've already taken care of the 2%, so that leaves 8% here. So when I add these 2 together, I get 10%. 12% use the bike, bus, and walk. So this entire overlap of bus and walk, because again, it doesn't say only, needs to add up to 12%. I've already taken care of 2, so that leaves 10% here. This says 5% use the bus and ride a bike. So this entire overlap of those 2 need to add up to 5%. So that leaves 3% for that inside chunk. Okay, 25% walk. So that means the entire walk circle needs to add up to 25%. So to figure out what's left, we would take 25%, subtract 10, 2, and 8% from it. And that leaves me with 5% that walk. That way this entire circle adds up to 25%. So there's 25% of people that walk total, but only 5% that just walk. They don't do the bike or bus. If I'm looking at, so I've taken care of that, using the bus, 30% of people use the bus. So I've already taken care of, so take 30, subtract the 10, the 2, and the 3% that I've already taken care of, and that's going to leave me with 15% that only ride the bus. And then for the bike, 20% ride a bike. So take that 20% and let's subtract what we've already covered, 8%, 2%, and 3%, and that leaves us with 7%. So the other thing that we're missing is what percentage of people don't walk or ride the bus or bike. So this outside piece in this rectangle. So to figure that out, we know if we're talking about a survey and we're dealing with percentages, the total should always add up to 100%. So if I take 100% and let's get rid of everything that we haven't counted yet. So we've got, or sorry, take away everything we have counted. So we've counted the 15%, 3%, 2%, 10%, 7%, 8%, and 5%. So I just took all these percentages and I'm subtracting them from that 100, and that leaves me with 50%. So that means that 50% of the people that surveyed don't use any means of alternative transportation. So to answer part A and part B here, part A is what's the percentage of people that only ride the bus? That would be 15%. What's the percentage of people that don't use any alternative mode of transportation? That would be 50%. So again, this Venn diagram was essential in really being able to break down this data, because if we didn't use it, it would be impossible to figure out if we're over counting people, which in this case we would be, because there's a lot of overlap in all of these circles where people are counted multiple times.